This is the story of the Vera Rubin Observatory, and if you have not heard what it just did, you are about to understand why astronomers are calling this the most disruptive machine ever pointed at the night sky.
Just minutes ago, the Vera Rubin Observatory revealed something scientists never expected to see. Designed to capture the universe in extraordinary detail, the powerful telescope has begun delivering new observations that could challenge what researchers thought they understood about the cosmos. But one particular discovery has quickly grabbed attention, raising questions scientists cannot simply ignore. As researchers examine the data more closely, the mystery only seems to deepen. So, what exactly did the Vera Rubin Observatory uncover? And why could this discovery change how we understand the universe? This is the story. Rubin Observatory's first images. On June 23, 2025, the team behind the Vera Rubin Observatory gathered in Washington, D.C. for a public event called First Look. After years of construction, testing, and careful preparation, scientists finally gave the world its first real glimpse of what this extraordinary observatory could see. One of the first major images combined the Trifid Nebula and Lagoon Nebula, revealing enormous clouds of glowing gas, dust, and countless stars. But the picture became even more remarkable when scientists explained what went into creating it. The image combined 678 separate exposures taken over roughly 7 hours and contained around 2 trillion pixels of information. Another early image focused on the Virgo cluster, a vast gathering of galaxies located millions of light-years away. Although astronomers had studied this region before, Rubin's powerful camera revealed an extraordinary level of detail, showing how much information could be hidden inside areas of space scientists thought they already knew. And this was the important part. Rubin was never built simply to produce beautiful photographs. Its real purpose is to repeatedly scan huge sections of the sky, comparing what it sees and searching for objects, movements, explosions, and changes that other telescopes might miss. Remarkably, the observatory began demonstrating that ability before its official 10-year mission had even started. During early test observations, Rubin was already detecting millions of stars and galaxies while identifying thousands of objects moving through our own solar system. Scientists were still checking the camera, optics, focus, calibration, and data systems, yet the telescope was already producing an extraordinary stream of information. That meant the first images were more than a spectacular introduction. They were an early warning of what was coming. Because if Rubin could uncover this much during testing, scientists had to wonder what might appear once the observatory began watching the entire southern sky night after night. Scientists unanimously agree that the Vera Rubin Observatory's specifications and capabilities are far beyond those of an ordinary camera. But will what this extraordinary machine discovers be something scientists have prepared for? Or will it exceed their expectations? Let's uncover the fascinating details. A giant stellar stream hiding beside a galaxy. One of Rubin Observatory's most fascinating early discoveries came from a place astronomers believed they already understood quite well. The target was Messier 61, or simply M61, a large spiral galaxy located roughly 55 million light-years away in the Virgo cluster. Astronomers had observed M61 for years, but Rubin's extraordinary sensitivity revealed something that had remained remarkably difficult to see: a huge, extremely faint stream of stars stretching far away from the galaxy. The structure extends roughly 50 kiloparsecs, or more than 160,000 light-years. To put that into perspective, its length is comparable to the width of our own Milky Way and may even exceed it, depending on how the structure is measured. So how did something this enormous remain hidden? The leading explanation is a dramatic cosmic encounter. Scientists believe the stellar stream could be the remains of a much smaller dwarf galaxy that passed too close to M61. The larger galaxy's powerful gravity may have gradually pulled the smaller galaxy apart, scattering its stars across an enormous trail through space. But the discovery matters for more than its size. M61 was not an unknown object buried in some unexplored region of the universe. It was already a familiar target for astronomers. Yet an enormous structure had been hiding around it, too faint for earlier observations to reveal clearly. That is exactly where Rubin's capabilities become so important. The observatory can repeatedly scan the sky with extraordinary sensitivity, allowing scientists to detect faint structures that might disappear in ordinary images. And stellar streams are more than beautiful discoveries. They act like cosmic evidence, preserving clues about how galaxies collide, grow, and absorb smaller systems over billions of years. Rubin was therefore doing more than finding new objects. It was uncovering pieces of ancient cosmic history that had been hiding in plain sight. Scientists were stunned to discover that the machine was revealing far more than they had initially expected from the target galaxy. But what else could still be waiting to be uncovered? What hidden discoveries could Rubin's extraordinary capabilities reveal, and how significant could they be for scientific research? Let's find out. Spots clues from the edge of the solar system. While astronomers were using the Rubin Observatory to explore distant galaxies, the telescope was also changing what scientists knew about the space much closer to home. During its early optimization surveys, researchers analyzed roughly 6 weeks of observations and identified more than 11,000 asteroids that had never been recorded before. The number was remarkable, especially because Rubin was still being tested rather than operating at full survey capacity. Among those discoveries were 33 near-Earth objects. None of the newly identified bodies posed a known threat to our planet, but finding them is still extremely important. The more accurately scientists know where these objects are and how they move, the better they can understand the population of asteroids traveling through Earth's wider neighborhood. Rubin also detected around 380 trans-Neptunian objects, icy bodies that orbit far beyond Neptune in the cold outer regions of the solar system. Some of these discoveries were particularly strange. 2 objects appeared to follow extremely stretched-out paths that could take them nearly 1,000 astronomical units from the Sun at their farthest points. That distance is enormous, and unusual orbits like these could eventually provide valuable clues in the search for Planet 9, the hypothetical planet some scientists believe could be hiding in the distant solar system. But Rubin was not only finding new objects, it was also improving what scientists already knew. The observatory helped refine the calculated orbits of more than 80,000 previously known asteroids, making the map of our solar system more accurate. Then another discovery added to the excitement. Research based on Rubin's early observations identified an asteroid roughly 700 meters across that was spinning faster than any previously recorded asteroid of comparable size. That revealed something important about Rubin's real strength. It was not simply seeing farther into space, it was watching enormous numbers of objects repeatedly, allowing scientists to understand their movements in remarkable detail. While astronomers were studying distant galaxies, Rubin was already detecting activity much closer to Earth. But how does the observatory send these alerts? And how quickly can its powerful system detect and report a new event? Let's uncover the astonishing details. Hundreds of thousands of cosmic warnings. The discoveries became even more remarkable when the Rubin Observatory began proving one of its greatest strengths: its ability to detect sudden changes across the universe almost in real time, allowing scientists to witness cosmic events that were previously easy to miss. On February 24, 2026, the observatory generated approximately 800,000 scientific alerts in a single night. Each warning pointed astronomers towards something that had changed across the sky, including moving asteroids, exploding stars, variable stars, and active galactic nuclei. This was a major milestone because Rubin was built to do something older observatories could not achieve on the same scale. Instead of simply taking individual photographs, It repeatedly observes enormous sections of the sky and compares new images with previous ones. That means a tiny change can suddenly become a scientific opportunity. If an asteroid shifts position, a star suddenly becomes brighter, an explosion appears, or a distant object begins behaving differently, Rubin can recognize the change and send out an alert. And timing can make all the difference. A supernova may brighten rapidly before fading away. A distant black hole can suddenly flare as activity around it changes. An asteroid can move across the sky while astronomers are looking somewhere else. Without a telescope constantly checking the sky, many of these events could pass unnoticed. Rubin is designed to reduce that problem by returning to the same regions of the southern sky roughly every 3 days. Over time, this creates something like a constantly updating record of the universe. But the sheer amount of information creates another challenge. Rubin is eventually expected to generate millions of alerts each night, potentially reaching around 7 million. No team of astronomers could examine every warning manually. That is why automated systems and machine learning are so important. They help sort through the enormous stream of data, identify unusual events, and direct human researchers toward the discoveries that deserve immediate attention. Beyond Rubin serving as a cosmic early warning system, what do scientists expect this extraordinary machine to accomplish in the years ahead? And how continuously will it monitor the universe throughout its mission? Let's uncover the astonishing details. Rubin's 10-year cosmic movie. On June 30, 2026, the Legacy Survey of Space and Time, better known as LSST, officially began. After nearly 2 decades of planning, construction, testing, and preparation, the Vera Rubin Observatory had finally entered the mission it was built to perform. For the next 10 years, Rubin will repeatedly scan the southern sky, returning to the same regions roughly every 3 days. The scale of this operation is almost difficult to picture. The observatory is expected to collect around 10 terabytes of information every night. Over the full 10-year survey, that could add up to roughly half an exabyte of data. But the real power of Rubin is not simply the enormous amount of information it collects, it is the fact that it keeps coming back. Instead of giving scientists isolated pictures of the universe, Rubin is building something much closer to a giant time-lapse movie of the night sky. Asteroids will shift across space. Stars will brighten and fade. Supernovae will suddenly appear before disappearing again. Black holes can flare as activity around them changes. Even distant galaxies may reveal faint structures that become easier to detect when several observations are compared over time. This constant watching could also transform the way astronomers respond to unexpected events. When Rubin detects something unusual, its alert system can notify researchers around the world. Other observatories can then turn their instruments toward the same location and study the event in greater detail. In that sense, Rubin does not have to answer every question by itself. It can act as the first observer, pointing the rest of the astronomical community towards something worth investigating. After roughly 20 years of work, the cosmic movie was finally rolling. But this was more than the beginning of a massive survey. It was the start of a decade-long search for answers to some of the biggest mysteries in existence. Aside from the fact that the observatory has been designed to repeatedly scan the southern sky, what is the ultimate purpose of this extraordinary machine? Is it designed only to advance scientific research? Or could its discoveries also have a meaningful impact on humanity? Let's find out. The answers Rubin is hunting for. The ultimate purpose of Rubin Observatory goes far beyond finding asteroids or producing breathtaking images of distant galaxies. Behind the enormous camera and the 10-year survey is a much bigger scientific goal: helping humanity understand some of the deepest mysteries in modern physics. At the center of that search are 2 names scientists still struggle to fully explain: dark matter and dark energy. Dark matter cannot be seen directly, yet its gravitational effects appear to influence how galaxies move and how enormous structures form across the universe. Decades ago, astronomer Vera Rubin studied the rotation of galaxies and found evidence that visible matter alone could not explain their behavior. Now, the observatory carrying her name will examine billions of galaxies, allowing scientists to study how matter is distributed and how cosmic structures have changed over enormous periods of time. Then there is dark energy, an even stranger mystery. The universe is expanding, but observations show that this expansion is accelerating. Scientists still do not know exactly what is driving that acceleration. Rubin's massive collection of galaxy observations could give researchers new ways to measure the expansion of the universe and test different explanations for what dark energy might actually be. But the questions do not end there. Rubin could also transform our understanding of how galaxies are born, grow, interact, and eventually change. The enormous stellar stream found around M61 offers a glimpse of what is possible. Such faint structures can preserve evidence of ancient encounters between galaxies, including smaller galaxies being pulled apart by the gravity of larger ones. As Rubin continues scanning the sky, scientists expect to uncover many more hidden streams, distant galaxies, unusual objects, and structures that previous surveys struggled to detect. And that may be the most exciting part. The deeper Rubin looks, the more it could reveal not only what exists in the universe, but how the universe became what we see today. Beyond Rubin's enormous collection of galaxy observations, which could provide new ways to measure the expansion of the universe, what could be the most exciting discovery this extraordinary observatory might uncover? And what important data could scientists gain from such a discovery? Let's uncover the details. The explosions that older telescopes missed. Perhaps the most exciting possibility surrounding Rubin Observatory is not the discovery of another asteroid, galaxy, or supernova that scientists already expect to find. It is the possibility that the telescope could detect something completely unexpected, an object or event that appears suddenly and disappears before researchers fully understand what they are seeing. Interstellar objects are a perfect example. These are objects that originated outside our solar system and travel through interstellar space after being ejected from their original planetary systems. If one passes through our solar system, it may arrive without warning and move quickly enough to be extremely difficult for traditional surveys to detect. Rubin's enormous field of view and repeated observations could greatly improve the chances of catching these visitors. Scientists believe the observatory could potentially discover several interstellar objects during its 10-year survey, with some estimates suggesting even more could be detected. But these mysterious visitors are only one possibility. Rubin will also be watching for failed supernovae, rapidly changing stars, active black holes, unusual asteroids, and other events that may not fit neatly into existing expectations. That is where constant monitoring becomes so powerful. Scientists do not have to know exactly where an interesting event will happen before they can find it. Rubin can scan enormous areas of the sky and allow unusual events to reveal themselves. A sudden flash could trigger an alert. A strange object could appear in several images. A star could change in a way scientists did not expect. An asteroid could follow an unusual path. And because Rubin keeps returning to the same regions of the sky, researchers have a much better chance of catching these events while they are actually happening, rather than discovering them after the evidence has faded. That is what makes this mission so unpredictable. The biggest discovery may not be something scientists are currently searching for. It could be something hidden in the data that nobody has imagined yet. And somewhere inside Rubin's endless stream of observations, that surprise could already be waiting. The most exciting possibility is that Rubin could detect objects and events that appear suddenly and disappear before scientists have enough time to study them. But will this extraordinary machine continue operating as planned throughout its 10-year mission? Or could unexpected challenges disrupt its ability to carry out the survey? Let's find out. The beginning of the real Rubin mystery. Everything Rubin Observatory has accomplished so far may turn out to be only the opening chapter. The spectacular first images, The enormous stellar stream around M61, more than 11,000 newly identified asteroids, hundreds of thousands of scientific alerts, and the remarkable discoveries from its early observations all happened before the observatory fully entered its decade-long mission. Now, the real survey is underway. For the next 10 years, Rubin will repeatedly scan the southern sky, creating an enormous record of how the universe changes over time. Scientists expect billions of galaxies to be catalogued, huge numbers of asteroids to be discovered, distant objects beyond Neptune to be tracked, and countless temporary cosmic events to be captured before they disappear. But there is another possibility that may be even more exciting. Rubin could find something that does not fit into any category scientists currently understand. It could uncover an unusual object hiding in deep space, reveal a strange pattern across distant galaxies, detect a completely unexpected cosmic event, or produce evidence so surprising that researchers may have to rethink ideas they once believed were reliable. That possibility is not simply science fiction. It is one of the natural results of watching the universe with extraordinary speed, depth, and consistency. The M61 stellar stream already showed that even a familiar galaxy can hide a gigantic structure that previous observations struggled to reveal. Rubin's asteroid discoveries demonstrated that even our own solar system contains far more objects than scientists have catalogued. And the massive alert system proved that the sky is constantly changing. Now, LSST will bring all of those capabilities together across an unprecedented survey. So perhaps the biggest question is no longer what scientists expect Rubin to discover. It is what the observatory might find that nobody is searching for. Because Rubin is no longer preparing to watch the universe. It has started. And somewhere within the billions of images and millions of alerts Rubin will collect over the next decade, scientists may uncover something completely unexpected, a discovery powerful enough to challenge old ideas and permanently change humanity's understanding of the universe. So, what do you think about the Vera Rubin Observatory's revelation? Could there be another mysterious discovery waiting to be uncovered? We would love to hear your thoughts in the comments below. Don't forget to like and subscribe.